In part 2 of section 12, we want to discuss some of the details about the graphs of a quadratic function. You will oftentimes be expected to graph a quadratic function to give you a visual representation of where it lives on the xy coordinate plane. And if you have a quadratic function, then there are 4 things that we can summarize about the graph. And this is Theorem 12.1. Number 1, the graph of your function will be parabolic shaped. That's not news. We've known that for quite some time, but it is still a true fact about your quadratic function. Second thing, we had mentioned a little bit of this on the previous example about the whole open up, open down. Here's the detail. The parabola will open up if your a value is larger than 0. It will open down if your a value is less than 0. So what we're talking about is if I had, say, y equals 2x squared versus having y equals negative 2x squared. These both have an a value. In this case, a is 2. In this case, a is negative 2. So when we talked about transformations earlier in the course, we had talked about negatives causing a reflection. So if my typical quadratic function, which is my parent function, I call that the typical function, opens up, then when you have that negative in front, that causes us to have a reflection over the x-axis. And that reflection is going to cause the parabola to then open down. So that's why the a value is going to be an indication of whether your parabola opens up or down. It has to do with transformations. Number 3 talks about the vertex point of the graph. So the vertex point is always going to represent the relative extrema of your function. If your parabola opens up, then that means that your relative extrema must be a minimum. If your parabola opens down, then your vertex is going to represent a relative maximum. And then the 4th item is the axis of symmetry. As mentioned on the previous example, the axis of symmetry is the vertical line that passes through the vertex. And it essentially cuts the graph of the parabola into 2 halves, the left half and the right half. Now, knowing that there's this symmetry can be beneficial in terms of graphing. When you're graphing, this means that you really only have to know the vertex and a couple of points to the right, because then you can just take those points and mirror them across the axis of symmetry, and you get 2 other points for free. So it really does help in terms of graphing, so that way there's not as many points you have to find. So these are the 4 main facts that we'll be using every time we look at graphing a quadratic function.